So welcome everyone to the OpenAGI Forum. I'm Eric Wong from CSDN here at the GoSim AI Paris 2025. We're delighted to be joined by Guilherme Penedo, machine learning research engineer at Hugging Face. So he just gave a fascinating talk earlier today about the OpenR1 project. So Guilherme, thanks so much for taking the time right after your presentation. So for everyone watching, be sure to follow the latest from the conference on the official GoSim X and the YouTube channels. So please take a brief introduction, Guilherme.
Hi, so I'm Guilherme. I work at Hugging Face. I work mostly on pre-training, so I've been part of I've worked on multiple large pre-training datasets, such as RefinedWeb, which was used to train the first Falcon LLM, and as well as FineWeb and FineWeb 2, more recently at Hugging Face. And since the start of this year, I've also been involved in OpenR1. So this is Hugging Face's project to publicly reproduce DeepSeek R1.
Yeah. For those who might have missed it, could you share the core message you wanted to convey about the replicating reasoning models and how I'm feeling now that the presentation is done?
I think the core thing is that first, that DeepSeek R1 was really an important step for the research community. While OpenAI's O1 showed that you can actually do this, DeepSeek R1 kind of showed us how. I kind of gave you some important pieces, but even then, we don't have everything. We don't have the data. We don't have a lot of the codes. And this is kind of what we still need to do as a community. We need to work together to build all these missing blocks, right? And the talk went well, I think. Yeah, feeling okay.
Is the QA session? Do you have the QA session?
Yeah, I had a QA session.
So what was the most interesting question or reaction you received?
So there are some interesting questions about how how different difficulties in the problems you use for this sort of reinforcement learning thing can have an impact. And because traditionally for normal pre-training, when people try to very selectively choose the order of data they show to train the model, it doesn't work super well. So some people found it somewhat surprising that there are people working on trying to see, like, okay, if we start with the easier problems and then the harder problems, does that change something or not?
Yeah. Can you show us the timeline? First, DeepSeek pop out in China, and Hugging Face just mentioned it, and you get into the work, and how long you get the OpenAI.
I think the timeline starts a bit further back, actually. So it starts in like September 2024 when O1 came out, and no one really knew how.
O1.
We knew
OpenAI
is O1, and we knew some things about what they were doing. So we knew they were using reinforcement learning. Chain of thought was a big part of it. So like a model reasoning with itself, thinking with itself. But we didn't know like what specific approach. And actually, it's very interesting because if you go look at videos of people, like researchers discussing it like shortly after, you have these like very complicated ideas and assumptions of how it could work. And in the end, it's kind of much simpler. And we didn't know, and like until DeepSeek R1 came out, O1 was really the only thing in the market. And DeepSeek R1 came, and now like people are
suddenly have an answer.
This new entire field of research just sprang up around their discoveries. And it seems like they've more or less discovered the same things that O1 did. So it's not like a completely different idea. It's pretty much the same thing. I maybe joined. Oops, sorry about that. So I maybe joined the project. Not sure, like March, something like this. I kind of started working a bit we did some stuff with math earlier on, and then my main interest has been code reasoning. So I think it's super interesting because the way you test these code problems, you need to have tests, and if your tests are not good enough, you're not checking if the solution is like fully complete, right, fully correct. And I also want to leverage how you can use models to also help you improve the verification. So like if you have some sort of problems, but you don't really have the verification infrastructure pipeline and so on, maybe you can also use models to kind of help you then create something you can use to do GRPO and all this.
Is it main text is code reasoning?
Code reasoning.
Code
exactly.
reasoning.
Yeah.
So let's rewind a bit. You started in aerospace engineers in flying in Portugal. So can you tell us about the initial passion? What was it like working on software for the ISS? It sounds incredible.
So I did my bachelor's in Portugal in aerospace, and then I did my master's in France, also in aerospace, in Toulouse. And this was a small student project we did where we sent a cube as like an experiment to the ISS. So I wasn't doing software for the ISS, just like a small student experiment. It was still pretty cool. We did send it to the ISS. It was like, we're not plugged it in, so It was interesting. But I always just liked software a lot. So I guess when the time came, I was looking both for things in the space sector and also in machine learning. And I happened to find a startup in Paris at a nice internship. And in the end, that's like how my career started. I went to the UAE to work on the Falcon models. And then I came to Hugging Face. And that was a bit like that. So
Wow.
I always liked programming a lot. So that kind of, machine learning was so exciting and kind of new. I joined the startup right before ChatGPT came out, or shortly after. No, before, way before, like a year before it came out almost.
Yeah, should be 2022. Yeah.
Exactly. Yeah.
So what was the turning point or the spark that led you from aerospace to diving deep into machine learning? So what is the gradual shift or a specific moment?
I guess I did this Coursera courses from like Andrew NG, like this deep learning.ai courses, and
in the time he was in the Google Brain.
Maybe
after Google
I'm not sure when it was.
Okay,
He had these courses that honestly I think are really good, and that's kind of how I got into AI, because from aerospace I didn't have a lot of background. I had some classical planning things to do for small robots and stuff, but not so much like deep learning at all. And honestly, it just sounded very interesting, and I kind of started looking for jobs and internships around this.
So self-learning.
Yeah, mostly, yeah.
Wow. So moving to Hugging Face, especially with these strong European rules, so what felt different or exciting compared to your previous roles? So how does that engineering background continue to shape how you tackle complex AI problems today?
So Hugging Face is really a really nice place to work, because we work in very small teams, but we have a lot of autonomy. So we kind of pick our projects, and we just need to, project should be impactful, but other than that, we just work. Everything we do can be released publicly, which is really nice, because in some companies you can spend months working on a project and then it's just like shelved into some place, never sees the light of day. And this is kind of a guarantee at Hugging Face. Everything I do, I can publish. I can put my name on it. I can say I did this nice thing. I want to share it with the world. And even when the results are not so good, you can also share things so that other people can learn from it. So I think it's a very unique culture, and it's a really nice place to work, and I'm really happy to work there.
Please, so then please introduce the RefinedWeb and the FineWeb to the audience.
So these are English pre-training datasets. So RefinedWeb was, I worked on it as part of this Falcon model. And at the time we didn't release the full dataset, only when had permission to release like an extract. So one of the first things that the Hugging Face was trying to reproduce and improve upon this old dataset. So this is like, you're basically processing the entire internet. It's petabytes of data, and you're filtering it, you're duplicating it, you're looking for the specific language, you're trying to remove the ads, the adult content, all this stuff that should not be going into training a model. And sometimes it's very not intuitive, right? Because you might think, okay, you look at a sample, a document, and you say, this looks good, but maybe it's not the best. And so we do a lot of experiments. We try a specific filtering step, we train a model with this, we train it without, we see what is better. And so we do a lot of very experimental approach. And this is like a very specialized thing that takes a lot of resources to like really process all these data and do all these experiments.
So RefinedWeb is suggesting high quality web data alone could be enough. So can you share the story behind the initial hypothesis? So So what's the skepticism you had to overcome? So even within the team, so how do you have the mind of the RefinedWeb?
So I can talk about FineWeb, which is the most recent one.
Yeah.
There was not a lot of skepticism, because we had already made Falcon and RefinedWeb, so people already kind of. But FineWeb, it was we had some earlier like bad results. For example, like when we were testing some things around the duplication, and it's really interesting because some of these things like really challenge your assumptions. So you have something that intuitively you think makes sense. It's probably what is best, and then you test it and it doesn't really work at all. You need to kind of take a step back and re-examine your assumptions and what you did and try different things. And in the end, we kind of made some interesting discoveries, specifically around like deduplication, which is this thing you do for these very large data sets. And how you do it is very important. Like you should not just remove everything. That's kind of what we were trying to do at the start. But there's actually, sometimes if you're very aggressive with the deduplication, you'll just be upsampling the worst quality stuff. So it's a very complex thing, but it's like, it's very interesting when you have to challenge your assumptions about a project and it just doesn't work out at start, and then you can, eventually you get there.
So we're scaling up the data to the 15 trillion tokens, right?
Yes.
So maybe a technical hurdle or something surprising you found in the data itself. So what challenge you encounter when you're scaling up to those high tokens?
So it's very challenging because I mean you're processing data in our case from Common Crawl, which is stored on S3 bucket, and at one point we're just sending too many requests to S3. You have like all these kind of like, for example, it's very expensive to have all these CPUs running, so we were using spot instances, which are these cheaper ones, and then there are periods where there's just nothing available. Like, for example, at Hugging Face specifically, we have this science cluster. So we have our own cluster with a few GPUs. And at one point, you want to run experiments, and you have other people with other projects, and you need to compromise a bit on the resources. So there's some things that are a bit challenging when you're trying to scale up, and especially when you go through this work of processing an entire data set, and you get to the end, and you kind of have this validation run, and maybe it's not as good as it was supposed to be, so you have to go back, and you basically kind of wasted a bit of money, a bit of time, and you kind of need to go back and work a bit from the start again. Yes, so there are quite some challenges.
Yeah. Besides the FineWeb, there's a FineWeb education, FineWeb EDU, so it focuses on educational content, and the FineWeb 2, which goes multilingual. Yeah. Yes. So how do you particularly define educational data or answer quality across hundreds of languages at scale? So it sounds incredibly complex.
Yeah, so for the educational part, so it's a subset of FineWeb. And so what we do is we take a model and we use it to classify specific samples according to some criteria. So the idea is you target content that could be appropriate for like not grad students, like grade school people, like high school students, that sort of thing. And you train a classifier to detect these things. And it basically, especially for very small models, where you're not training for very long, and like it's really important to have like the best kind of data. For bigger models, maybe you want more diverse data. So maybe it's not maybe you do this more at the end, right? And for FineWeb 2, it was really super challenging. Was much more challenging than I expected because I didn't even know at the time that some languages don't have like space, for example. Like in Chinese in particular, you can write without like spaces does not have it's not a word boundary. Right?
Yeah.
So this stuff was many things, and for many languages have other things like Thai does not have punctuation, and having to deal with all these different scripts, all these different the filtering you need to tune it to every single language. Like I cannot filter. Like one of the filtering we do for FineWeb English is we check how many of the lines end with punctuation. Usually it's better quality content. I cannot do this for Thai because it removes everything. Yeah. So you need all this tuning per language, and we supported like thousands of languages. So it's a lot of work. Even identifying the language is a real big challenge. So I would say like FineWeb 2 was a huge challenge in general. Yeah.
Sure. So you say your main test is code reasoning, and in the O1 project, OpenR1 project, so you focus heavily on curating reasoning data.
Yeah.
So can you walk us through what makes data for math or code reasoning so different? So is it just about correctness, or there's
so it's more the difficulty of the problems, right? Because you can take a thing which is like an equation, and you can kind of, depending if it's quite somewhat simple, you can just tell the results right away. But for some problems, you really need to decompose it into steps, and you need to solve each step before you can do the whole thing. Or you take this kind of this programming kind of contests which is like this competitive programming code reasoning stuff, and it's really challenging things. Like it's not some basic like make a function that does this. It's more like you have this problem and you need to make some assumptions about it. You need to it's very mathematical in a way. Sometimes you need to kind of prove that this is the optimal solution, that you can use this greedy algorithm, or that you can actually use some some other kind of tool or algorithm that actually makes sense and that it actually solves the problem in the specific time constraint. So it's very hard kind of problems. Even like real humans, that we send the best people to these Olympiads to compete in this sort of thing. So it's really kind of challenging in problems. So that's the main difference, and that's why this kind of extended thinking helps, because you can really go through the whole steps. You can reevaluate everything you kind of concluded, and and arrive at a usually better response.
Yeah. So about this DeepSeek, there has another hot topic about distillation.
Yeah.
So what's our thoughts on these trends of models, teaching models? Are these risks or limitations we should be aware of as this becomes more common?
So part of it is already quite common. So for example, like when you're training on a new model, like even for pre-training, you're training on the internet. And the internet now has many model-generated content, right? And some of it maybe is easy to find because maybe it says as a large language model, or certainly here is so these things you could kind of find, but in general you can't really you don't know. Like you have some content on the web, you don't know if it was human generated, if it model generated. So we are already all training, like these newer models are all probably trained on, even, it's unintentionally, but it's just like if you take the internet, it's in there and you can't really detect it. So we're already kind of doing this. I mean, there are these people, like there are all these papers where you have this model collapse thing. I don't think this is the case. I mean, we'd already be experiencing this if that was the case. And usually the experiments they show is a very unrealistic scenario where you take a model, you train on its outputs, you take that model, you train another one only on its outputs, and so on and so on. So obviously this is an extreme case that no one does, right? So you always have some human data in there, maybe you have some high quality model generated content. Generally it's fine. And for distillation in this reasoning context, I mean, it's just really interesting because it basically shows that so these gains that you get from this like GRPO, all this stuff,
GRPO, yeah.
you really need a strong model. And this maybe shows why before we didn't have this going on, right? Because models were just not good enough. Because if the model can never actually solve the problem, you can never improve. Because the idea is you generate many different possible answers, and some are correct. If none are correct, you cannot really do it. So it's nice that there's this easy way to apply to these gains from a bigger model to a smaller one. And you can still get a reasoning model without doing all the reinforcement learning part.
Yeah. So from your hands-on experience, what feels more impactful right now for improving RL? So like refining the RL algorithm, like to change PPO to GRPO, or improving the quality and the diversity of the training data generated?
So I mean, I always work mostly on data, so my answer is data. Yeah. But obviously there's possibly things you can do on the algorithmic side to improve. People have been trying to correct maybe some biases in the algorithm, where it maybe incentivates the answers to be way too long or something. People are working on this. But to me, data is really the most important. Like if you have a good variety of problems and you have enough hard problems, and then you can, I mean, anything you can postulate in this verifiable format, you could potentially solve. Like if let's say you have a medical data set of like medical diagnosis, I mean, you could do it with this, right? So if you have enough data, you could, anything you can, so if you have the data, so the actual problems and way to verify them, then you can use this thing. And that's really nice because anything that you can put it this way, you could use.
Yeah. So there's so many benchmarks now. So how are current benchmarks for truly evaluating of if a model can reason versus just pattern matching on specific problem types?
I mean, maybe there's some pattern matching, but even we as humans do this. Like people training for this Olympiad contest, they train on many hundreds, thousands of problems, and obviously there are some things they see that resemble what they train on, right? That's kind of the idea. I mean, I think that's fine. I don't think that doesn't mean they're reasoning. But honestly, like benchmarks are a big thing. So you do need better benchmarks. You need to always update them so that models don't just, aren't contaminated with the previous ones. So one cool thing is this sort of like competitions that happen every year, where you have people like at the highest level making problems. Like you take the math Olympiads or the informatic Olympiads. So every year you basically have a fresh, uncontaminated benchmark. So this is we constantly need to update our benchmarks. This was already the case before, and even more so for all this reasoning part.
So let's talk about Hugging Face. Hugging Face is a champion of open source. So how do you personally see the dynamic between open development and closed the models playing out in the next few years, especially regarding safety and access?
Yeah, I mean, I usually don't buy the argument that you need, because proponents of public models are like, yeah, it's safer because we control what is going on. I don't think it's safer if you have one player in control of everything, right? So monopoly is never safe. Transparency is what gives you safety. So if you can see what's going on into these models, their training data, their codes, you can take the model and actually examine its weights, its log probes, everything. That's what actually can give you safety, because then you can study the models, you can see what they do, how they were trained, the data that went into it. To me, this is the way to safety. And obviously, it's very easy to argue for, just we should be the ones doing it, no one else. Because we're the ones who can make it safe. I mean, when obviously you have a lot of money to profit from these things. So to me, I don't. This is not a good argument to me. I think open source is really the way, especially on such a transformative technology, right? Because what can happen is that which is kind of what usually happens on these new technological advances. You have a few players, a few countries that kind of get ahead, and the others are just left behind. So this is really a way if we actually work in the open, we can have everyone contribute and benefit from these tools, which can be like a huge productivity boost, right?
Yeah. So what is actually the open sourcing AI area? Because, Jeffrey Hinton, the guy, the Turing Award and the Nobel Award The guy, yeah. The Turing hinted the open weight is just like showing the atomic bomb. So, what do you think?
So I think
about?
it's not only better than nothing, but
Yeah.
it's not fully open science, right? If you make a report saying we did this amazing model, and these are the experiments we did, but you don't actually have we can actually not actually reproduce your experiments. It's not actual science because science needs to be reproducible, right? And again, like you can say, our model is really good at these benchmarks, but maybe you just trained on part of the benchmarks. We don't know because we don't have your data, right? So not being able to check is really a problem. Obviously, it's already like what DeepSeek did is much better than what some other companies do, which is they don't share anything. And they still share like a paper. They kind of went through what they did. So it's already a start, but I would really like to see companies sharing more. Obviously, have all these fears as well because you have this very uncertain legal landscape, which kind of incentivizes people not to share the data because they can be sued. So obviously, I think even like from a policy side, there's some work we should do to ensure we actually, at least for science, we can actually share what we're doing and what works and what doesn't, so everyone can look at it.
Yeah. So looking beyond OpenR1, so what's one area in AI? Maybe a specific capabilities, data challenge, or an ethical consideration that you find yourself thinking about a lot lately. So what excites or perhaps worries you most about the near future of AI?
So I mean, from my personal work,
Yeah.
I want to continue work on pre-training. So I think one key thing is how do you kind of measure diversity in data? It's quite specific. I think like in a more broader landscape, I think like agents and robotics are kind of two big things coming up now. And especially for agents, I mean, you can kind of use this reinforcement learning approach for agents. I mean, there's nothing preventing you from doing, right? So it can really supercharge. It's mostly infra work, like being able to use all these tools and everything. But it's really an approach you could use. I mean, you just have the model call tools. You check the result. If it's good, then it was a good. You assume it's a good tool call, right? So agents and even robotics, because robotics is a very early stage in terms of this open source kind of thing. Usually, each researcher has their own tools, their own stack, their own robots. But having something that anyone can either 3D print a simple robot or buy a cheap robot and just have this software you can download from Hugging Face to do these things. I think it's really cool, and we actually have a team working on this at Hugging Face.
I see. So if you could give one piece of advice to someone just starting the journey in ML's research today, perhaps transitioning from another field like you did, so what would it be?
So I think it's still very early. And it will be for a while. So it's hard to be it's easy to be overwhelmed by all this, like all these papers you see, all these new things coming out. But it's still a field where you can learn a lot in a few years and be able to meaningfully contribute quite quickly. Like you find this niche, and there are many niches where you can explore, and you can have a real contribution very. So like, don't be discouraged. That's my main advice.
So Guilherme, this has been an absolute fantastic conversation. Thank you for sharing your journey, your deep insights into data and reasoning, and your perspective on the wider AI landscape. So I really appreciate your time, especially after your talk. So for everyone watching, don't forget to follow Guilherme's work on
Hugging Face, Twitter.
How about personal sharing? How about your personal sharing?
Yeah, I mean, on Twitter, I
On
share,
Twitter,
usually I have my...
Okay. And keep up with GoSim AI Paris 2025 highlights on the official GoSim X and YouTube channels. So thanks for tuning into the Open AI Forum. Thank you.